Alright, this is another video over integrals. This is problem number 22 from the homework. It tells us to integrate from 0 to 1 e to the x over 1 plus e to the 2x dx. Okay, so one thing that you should remember or know as far as exponents go, looking at e to the 2x, that's the same thing as e to the x squared, just because you multiply exponents together. So now that we know that, we can go ahead and start setting everything else up for our substitutions. So, excuse me, let's just let u equal e to the x, and the derivative of e to the x is just e to the x. So that is going to be du is going to be equal to e to the x dx, and dx is going to be equal to du times 1 over e to the x. Alright, so now we can go through and make our substitutions. So we're still going to have a integrating from, we could do 0 to 1 or just leave it blank, since we're going to be putting everything in terms of u, and we could go back and figure out what to use as our u numbers, or just make like a little mental note and sub everything back in terms of x at the end of it, and just use 0 to 1. But so we could have like e to the x over, and you could put u, but in order to make things cancel out and look nice, I'm going to leave e to the x as e to the x plus, or over 1 plus. Now here I'm going to sub in u, so it's going to be u squared, and dx was du times 1 over e to the x. And now you can see why I left the top e to the x there, so those will cancel out, and we're going to be left with the integral of 1 over 1 plus u squared du. And if you saw the video that I made of more trig stuff, then we know that whenever we integrate that is the same thing as tan inverse or arctan of u, and the du goes away, and so we're still integrating that. And then whenever we put that back in terms of, and I just put a little asterisk since we know we still need to have our integral, or our interval for the integral there. And so then whenever we sub in our u, we get the integral from 0 to 1 of tan inverse or arctan of e to the x. So we take this over to the next slide. Okay, so now that we have that, we need to use our handy dandy fundamental theorem of calculus formula, which is f of b minus f of a. And so we'll have the tan inverse of e, and we sub in our b for x, so that's going to be e to the 1 minus our tan inverse or arctan of e to the 0. And we know that anything raised to the 0 is 1, so e to the 0 is just going to be equal to 1. Alright, so now we'll clean that up a little bit more, and we're going to have our tan inverse of e to the 1 minus our tan inverse or arctan of 1. Okay, so a little thing about the arctan, with the regular sine, cosine, tangent, all that, we put in an angle, and that gives us a number, and the arctan, or the arc or the inverse of any of those, gives us an angle because we're using a number. Alright, so we know that tangent is equal to sine over cosine. Okay, so as far as the angles that we use, what in regards to tangent would give us 1? Well, if cosine was the square root of 2 over 2, if sine is square root of 2 over 2 and cosine is square root of 2 over 2, that would give us 1. Alright, and so what angles give us the square root of 2 over 2 for sine and cosine? Well, that's going to be pi over 4. So we know that the arctan of 1 is equal to pi over 4. So then we can clean that up and simplify that down just a little bit more. So we're going to have the tan inverse of e to the 1 minus pi over 4 as our final answer.